Our presenter for the 1:40 p.m. time slot is Nathan Pomles. He is from Columbus, Ohio, and will be sharing with us his capstone project, Traveling Museum Exhibit Design. Please join us in welcoming him.
All right. As Nick said, my name is Nathan Pomles, and this is my capstone project on museum exhibit design. Reason I chose this project is because it was personal, had personal meaning to me. I actually wouldn't be an industrial design student giving this presentation to you all if not for a children's museum exhibit I went to as a kid that sparked my curiosity to create. When I was a kid, I went to the Indianapolis Children's Museum and saw a robotics exhibit that sparked my interest in doing middle school first robotics and then continuing that through high school. And through that, I learned that I loved CAD, which made me want to be a mechanical engineer. Something called pre-calculus I took in high school quickly changed that aspiration from being engineer to designer. And I also chose this project because it was an architectural project, which was just of interest to me, as well as it gave me the opportunity to do a lot of CAD work. So to begin, when I got into the project, there were a few sources for just designing museum exhibits I looked at. I sent out email interviews to museum exhibit designers across the country and heard back from about 10 of them. And they just gave me general advice on how to design exhibit and what to consider. I read a lot of AAM articles, which is the American Association of Museums. I read a book called Designing Spaces for Learning, which was super helpful in just realizing how I can create interactivity in the exhibit. And then there's a local company called Roto that does space and exhibit design. And I actually met with them and they advised my project throughout the whole process. And they were a huge help. And then my key findings from all these sources were that interactivity and visual engagement are paramount in any museum exhibit, regardless of age. Concerning museum exhibits for a younger audience, a concept of family learning is important, and I had to learn what that was. And what that is when children go to a museum, they're accompanied by a guardian or their parents. They can ask questions and also participate with them. So having exhibits that can, features within the exhibit that can be used by multiple people at a time. And then material selections are very important. And there were trade-offs in choosing various materials over the others. And I learned about those in my research. So narrowing it down to like a who, what, and where, I wanted to design this exhibit for children's ages 4 through 14. On the younger end of that age spectrum, the objective of the exhibit would be to just encourage a sense of curiosity and creativity in participants. As a secondary audience, I wanted to design for adults accompanying children. As I mentioned, that concept of family learning. Making sure there's adequate signage that if they don't have an answer for a child's question, they can actually just look at the signage and have that information readily available. And then another audience I kind of wanted to design for was people assembling the exhibit, and I'll get to more of that in a second. It is for a museum topic, I wanted to design a exhibit about power or electricity, how we generate and use it. Chose this issue because it's socially and politically important in today's climate and culture. However, it can be presented in a non-polarizing way, which was key for this exhibit. And then in terms of where I wanted to install this exhibit, I actually ended up making this a traveling museum exhibit. So various museums around the States have spaces dedicated in their museum buildings to host traveling exhibits. So I just had to make sure in designing this exhibit of my own that it was versatile and could be set up in a varied number of spaces. So my objectives were design an engaging space in which children can learn. Again, to me, it was just important. I wanted to foster that sense of creativity and curiosity. Create exhibit features that can be readily assembled and disassembled. As I just mentioned, this is a traveling exhibit, so might go to a museum for a few months and then have to all be packed up onto a semi-truck for transport. And then my final objective was actually to ensure that all the exhibits could fit on a semi-truck. And before I get into more of the renderings and my work, I just want to give a preview of I'm going to cover in this presentation. I'll just do a brief overview of all the exhibit features I made. I'll actually then break down each exhibit feature, show several different layouts that kind of show how this could be set up in different spaces, depending on, different museums are going to have different spaces for hosting a traveling exhibit. And then I wanted to end with a transportation layout, which is where I took everything and actually show it packed onto a semi-truck. And to begin, kind of with my process, it was just iPad sketches, very quick. I actually would set a 5-minute timer, draw whatever came to mind, and then set another timer and iterate upon that. And when I felt comfortable with what I had, I took that into a quick SketchUp model, which also just had a 5-minute timer. And that just gave me a sense of scale working with this project. Took those SketchUp models and moved them over into SolidWorks, where I actually hashed out all the parts and more details. And then I recreated those final SolidWorks models in SketchUp and did layouts using those. So an overview, I designed, follow the mouse cursor around, there's an entry feature, a solar power feature, nuclear power, coal power, seating assembly in the middle. And it's important to note that the design of this is actually inspired by a generator within a hydroelectric dam. Hydroelectric feature over here, wind power feature, geothermal, and then an exhibit that talked about pollution levels. And beginning with the hydroelectric feature, this was meant to be, again, I'm designing for a younger audience. It had to be visually engaging and also interactive. So this is an exhibit where I wanted to simulate the flow of water through a hydroelectric facility. So you can see the diagram down here. There's a aerial view of a dam, as well as this element that represents a power generator and an intake. I didn't want to pump water through this feature. It being a traveling exhibit, that just seemed like a lot more work and hassle than it would be worth. So I quickly came to a realization I need something to simulate water. And so I decided to use, there'd be balls within the exhibit that would go up the spiral lift. They'd kind of pachinko down these pegs, fall down here. And when a ball passes through the intake, these lights would light up showing the idea that this water flow is generating power. And then hidden right out of view in this render, there's two pinball paddles that can be controlled with the buttons on the front, and allowing it to be interactive, as well as kind of a gamified explanation of how hydroelectric power works. So this is just a basic breakdown of the chunks of assembly. As I said, this was supposed to be a transportable exhibit, so everything kind of breaks down for that transport. Just some elevations showing scale. This is another key component I designed. As I said, I wanted to design with the people assembling the exhibit in mind. So every sub-assembly of each feature has these decals on it. Each one has its own lettering, so you'd have like 3A, the 3B. Each one has its own color on the square, as well as a shape in the background right here. And what that does is, like over here, you see 2A. On this exhibit, where other sub-assembly of the exhibit, there'd be another sticker that said 2A, and they would match up. So you get that color coding and that numeric coding as well. Here's another example of that. So this is view on the right is actually this top assembly on the left. You can see where it says 1A here, and then 1A where the assembly would set. Another important thing to show in this render is that I used a lot of 80-20 in this exhibit. And what this material choice does is allow you to have very easily insertable components. You can see these features down here are just clamps. This just slides in and locks down, and then can just be pulled right out for easy disassembly and assembly. And so with this exhibit, this is my primary one, which I show off the decals and all the parts. I didn't have time to do this for all the remaining features just due to time constraints, but this goes to show I did put a lot of thought and effort into how these exhibits were designed. There's actually 1,200 parts in this assembly right here. And then moving on to the geothermal feature, it's a little more simple in nature. It has a valve right here that users can turn that determines the power of a blast of air that simulates steam, spinning this turbine in the middle. and that turbine spins, and then there's this screen over here, depending on how fast it spins and how fast of or powerful of a blast of air the user selects. This shows that more power is generated from the higher blast. Elevation, as well as this is just the chunks it would break into for transport. And then there's a solar feature. This functions kind of like a giant Hot Wheels track. What you have here is the start line right here with light bulbs above it. And you'd have little solar powered model cars set into grooves on the track. Users could come over here and queue up. There'd be a button right on the end of these handles. And then once everyone or however many people have entered, the exhibit starts a countdown, and the users see how fast they can turn the cranks, which in turn determines the brightness of the light. The brighter the light, the faster the solar car will go. And that's to show that when it comes to solar power, more exposure to light equals more power. But it was a simple way to explain it to children, also in an interactive format. And here's those assembly parts, as well as elevations showing the scale. And then for the wind feature, as I said, I want everything to be highly interactive. And what better way to show that wind can generate power and get an interactive and tactile experience than actually stepping into a wind tunnel. And within the middle, there's a pegboard right there, and the participants could stick little windmill style elements and interactive elements into that and watch them interact with the wind tunnel. It's just a very tactile way to show that the wind can generate power. And there's the assembly breakdown as well as the elevations. This is one of the larger exhibits features I made for the space. This would be the coal feature showing the process of coal power. So what I did is I went into Illustrator and drew a kind of kid-friendly, readily understandable diagram of the insides of a coal power plant. And you'll see all these track elements right here, as well as there's spaces where balls are stored in these trays on the bottom can be inserted. Using a combination of these tracks and vacuum tubes, they actually flow throughout the space and then slide around on the tracks, providing a very visual, engaging, and fun way for kids to learn about this process. And here's the breakdown and the elevations. This is the largest overall exhibit or feature within the exhibit. And then the nuclear power feature, designed it actually to look like two nuclear stacks. You have within each stack, there's a interactive console, and this has a very simplified walkthrough designed for people of younger age to just explain the basics of how their nuclear power is used to generate electricity. And then in between the two stacks, there's an arcade table that pretty much has a game that involves kind of bouncing an isotope, which is what happens within a reactor and part of nuclear particles. And it would be function like a real life Pong game. And here's the breakdown for that assembly, as well as the elevations. And then the final exhibit feature is the pollution feature. This is a trivia style game where users could queue up and use these buttons here. Questions would be displayed on a larger central screen. These buttons could be used to select like options like A, B, or C. And then points are tallied on the screens right here. And it's just a way to show that some exhibits or some methods of power do generate more pollution than others. However, I didn't want to get into like, then we should use this one over the next because I wanted to make sure this exhibit was non-polarizing in nature. This would be the entry feature. I designed the two supporting columns to look like smokestacks from a coal power plant, as well as I ended up titling the exhibit Power Works, and then just the tag for it was exploring how we generate electricity. Breakdown of how that would go apart for transport, as well as elevations for scale. And then a seating feature. And this is, as I mentioned earlier in the beginning, modeled after a turbine within a hydroelectric power plant. This top part actually would rotate. It could be turned off to save power when no one was in the exhibit. where the museum was closed for the night, but it would rotate and provide a visually engaging element as well as place for parents to sit. If they aren't participating with their kids, they can still keep an eye on them as they go through the exhibit. Here's the assembly breakdown for that, as well as the elevation. Before I move into exhibit layouts, I wanted to briefly talk about signage. I did generate some signage templates to use in my renderings of the space. The breakdown of the signage is fairly simple. There's a title, in this case, hydroelectric power. And then there's an introductory statement right below that. And the purpose of that introductory statement is that not everyone reads all the signage. They typically read the title and whatever's right next to it. And the idea of the little introductory statement is that if that's all the person read, they walk away at least understanding what hydroelectric power was, as well as when I mentioned family learning and kids asking questions to their parents and having signage readily be available to the parents for reference in case they don't know the answer to a child's question. They can look right here and quickly get, this is the basics of what it is, and give that child an answer. Right below that, I use imagery that just captures user attention, and then a caption at the bottom. Time constraints, I just didn't design signage for every single exhibit. Instead, I created these templates you see over on the right, and those will be used in the space renderings. And I also made several murals that would be cloth, and these would be 10 foot by about 6 foot, or 8 foot, depending on the illustration. And they could be hung from the ceiling in any space that would host a traveling museum. And they just served to visually tie in the whole space, frame some of the exhibits, as well as just provide visual interest and color to the space. And then moving into layouts, I created several different layout options, this being the first one. Purpose of creating several options was that this exhibit, being a traveling exhibit, would be installed in a variety of places. I just wanted to show the versatility of the features I'd created. So you can see there's the murals on the wall, and then the user flow pattern through the space is very semicircular, coming in one door, entering out another. It's all on the same floor. It's also important to note that the floor and the walls I kept gray. That's just because I don't determine what space this goes in a museum. I wasn't designing the physical room, so I just didn't want to highlight too much attention to that. And then there's these power line elements right here, and these serve to help tie in all the exhibits in the overall space. So here's a top view, aerial view of that. Again, just a semicircular flow, fairly straightforward, keeping the seating central so that way if parents need to sit down, they can see wherever their kids are in the exhibit. Entry view for that. An interior view focusing on the left side of the room. And a view focusing on the right side of the room. You'll also notice these pillar elements that you can see here. These would just have signage and pictures of different power plants, and they just provide visual engagement as well as serve to tie the whole space together. This would be layout 2. It's a little more linear in its layout. It's just one corner there and then 2 separate entries and an exit. Keeps the same kind of flow as layout 1. It just shows that the exhibit can be laid out in a different manner. And this would be a view for the entry of that kind of layout. An interior view. Again, these elements all framing the exhibits, helping tie everything together. And then for layout 3, I wanted to show something a little different. In my personal experience, I've been to several museums that do this. The exhibit will be broken into several different rooms. These long corridors are actually ramps that go up a quarter story each, so that when you exit in this final room, you're actually a floor above where you started. And this is a fairly common setup within museums I have at least been to. And just for not being redundant, I didn't do interior views of that. Instead, I like to show you the transportation view. This is every exhibit broken down, those pieces I showed you earlier, how they blow up. They're all put on 4x8 pallets and stacked. In actuality, there would be cloth and protective materials between each piece, as well as ratchet straps connecting them to the pallet. However, to show all the pieces and how they stacked, I didn't include those in the CAD. Um, Here's a view of that, just showing a little more depth to it. Everything that I've shown you in the exhibit spaces does fit onto one standard size semi-truck trailer. Um, and then just with a pallet jack, the assembly crew can just unload pallet per pallet, which each pallet, each exhibit is on 1 or 2 pallets. And to recap what I've shown you, I wanted to, my goals were to design an engaging space, educate visitors about power, mostly children, so it's done a little more of a simplified way, encourage family learning, provide easy assembly to those who set up the exhibit, ensure ease of transportation, and then most importantly to me, I just wanted to foster a sense of creativity and curiosity in participants. If I could accomplish that in one person, if this exhibit or something like it was ever made, that would be, to me, mission accomplished. And then a special thanks to my teachers and advisors for their guidance and knowledge. The museum staff responded to my email interviews and helped me in my research. And then huge thank you to the team at Roto, who advised me several times throughout this whole process of making this project. I could not have achieved what I did through this project without their help. And so any questions? The number's right down there. Gabe will monitor them and ask whichever ones he sees fit. Thank you.
Thank you, Nathan. First question, can kids reach the high tracks on the wall of the coal energy exhibit?
So let me back up to that exhibit real fast. My keyboard's being a bit finicky. Probably didn't explain this too well because I speak this way too fast. So using vacuum tubes, all these are where the balls would come out and flow down the track. The inserts are right here where there's these colored rings. So they're at the reach of children 4 and older. The rest is all accomplished. So balls would fall down the track with vacuum tubes inside the exhibit. So as long as you put the ball in down here, it then goes through the rest of the track on its own.
Good. Keeping kids in mind, how do you account for the fact that children are apt to use features or items of the exhibits incorrectly?
That came down to a lot of material choice and design choice. So if something got set on the wrong track, it wouldn't break the exhibit, for example, concerning this feature. And the rest are pretty straightforward, where they can't be misused. The worst case someone could do is climb on something, and I tried to make that as hard to do as possible. For this exhibit, everything is set at 32 inches, which is lower than the standard counter height, but that also was a purposeful decision because that's a height that children have a hard time climbing up onto when they're younger and more apt to do that. It kind of dissuades them just height-wise. And then if something does get misused or kind of physical rough wear, kids just kind of being rough with stuff, the material choice of using a lot of wood paneling, for example, let me go back to the hydroelectric feature. The wood paneling here is just coated. Wood was chosen just because it can be, if it gets scratched or whatever, it can easily be sanded off as well as replaced. It's very cheap. And then you also have this protective baseboard, which not only is an aesthetic element, it actually is a foot guard as well. Hopefully that answers that.
Yeah, I think so. Do you have an estimation of how long this would take to set up or tear down?
It wasn't the focus of what I kind of focused on with the project. However, just in my own experience of setting up a few things similarly to what I did with robotics, we'd actually set up like convention exhibits or kind of what you'd see at a trade expo. And that took about a half hour to 40 minutes per, but we didn't have assembly decals. We also didn't have it in large chunks. So my estimate was about 20 to 25 minutes to unload one off the truck and put it up, which considering it sits in an exhibit for a month or two is not too bad.
Yeah. What CAD programs did you use?
Um, it was a little bit of a journey for me. I started out actually taking these sketches shown here, putting them into SketchUp to get a sense of scale. They weren't these same models, they were much rougher versions of these. To do all the details, I recreated all those in SolidWorks. The one that took forever was this assembly where I thought out every detail. Um, and these same kind of like the 80-20 mechanism and assembly decals would be applied to the rest of the features. I just didn't have time to do that in my CAD. But these final layouts, I actually took my final SolidWorks models and went back to SketchUp and recreated them all again, which took about 24 hours. It wasn't that I could actually drag these from SolidWorks and put them in a SketchUp. I had to build them from the ground up. So a lot of SketchUp, a lot of SolidWorks.
Have you gotten any feedback from anyone in the museum industry about your project?
So actually, before I gave this capstone, I gave this same presentation to Roto last week, a little over a week ago now. And they were absolutely blown away. The last time I met with them before that, the only thing I had done was that hydroelectric exhibit. And then within 3.5 weeks, I kind of had done everything else you see, the murals, every other exhibit, the signage, the layouts. It was a bit of a rush just to get done to their time frame where I could present to them, but they were actually very impressed and thought I had just had a good attention to detail, more than they were expecting. So that's the feedback I got from people in the industry, was that it was a job well done, which was very comforting.
For sure. Someone asked if the rendering was done in KeyShot.
So these layout renderings are just done in SketchUp, but the exhibit features like this are all done in KeyShot.
What has been one of your favorite museum exhibits that you've been to?
I'm gonna sound like the kind of metalhead weirdo I am, but the history of burial practices. It was cool to see like so many mummies and stuff in one exhibit. Um, and then there's a museum exhibit on history of black metal. So I love that as well. I was a weird kid.
You know, I asking that question, I should have expected those answers. That's good to hear. Let's see, other questions. So it was a robotics exhibit that you got you started, and you've done a little bit of robotics since then. That kind of introduced you to industrial design.
A lot
Do
of
you have any
robotics.
interest in? Yeah. Do you have any interest in returning to it?
From the standpoint of more the actual like, do I want to design robots? No. From the sense of the actual first robotics program, I actually used to coach a team towards the end of high school when the teams I were in, I aged out of. I coached a middle school team for a year and a half. That was really fun. I'd love to return to that one day just because I actually used to also at a Boy Scout summer camp teach robotics to middle schoolers, and I love working with that age group. So I'd return to it in that fashion.
Great. Would you like to go into exhibit design? Is that where you are hoping to go?
Any form of interior space design would be preferred, but I also am perfectly happy doing products. I actually just chose exhibit design for a project too because it was something I hadn't done yet in terms of designing an overall cohesive space with several features. And so it was meant to be a challenge for me, as well as designing for a younger age group. I hadn't really done that.
Yeah. All right, I am going to hand the floor over to Carlos so that he can chime in. Carlos?
Okay. Okay. Thank you, Gabe. Hey, Nathan. Your computer modeling work and imagery is great. Uh, I remember seeing it when you were completing the work in the past several weeks. Um, I have a question related to how long does it take to put the whole thing together. But I was wondering if you thought about how many people maybe is required to assemble the exhibits, or
3 to
have you
4,
done? Mm-hmm. 4?
3 to 4, which is a fairly
3
low
to 4.
number.
Uh-huh, uh-huh. Okay. And another question, I'm curious, is this exhibit monitored or controlled from a central computer maybe? Or how does it work from that point of view?
Terms normally in a museum, it's just people go in, they
Mhm.
can buy the traveling exhibit will have its own ticket price, and then there's someone at the entry to the exhibit just monitoring how many people go in at a time, as well as making sure everyone has, you probably, most museums, you get a different colored wristband or something like that. Beyond that, it's having a few, the museum who hosts the exhibit will have a few people within the exhibit just monitoring, making sure everything's being used properly. That's also what they do in their own exhibits. They actually have people who are set aside to do that, most of them who can host traveling exhibits.
Mhm.
Have people who that's their job is wherever traveling exhibit is in, they kind of stand monitor it and monitor admissions to it.
Okay, yeah, but I guess I was uh, asking more about um, having a central computer that controls the actual exhibits from electronic or electronic point of view, maybe.
Oh, okay.
You know what I mean?
Yes. So most of the time it is museums that like exhibits can be turned on or off. There's a switch on each feature, and that's just due
Okay.
to the fact that you don't know what kind of electronic infrastructure a museum's
Yeah.
going to have that's hosting the exhibit.
Hmm. Great. And the company that you were consulting when you were doing this project, have they showed any interest to offer you either a position or buying into your design?
They were running an internship that, with everything that's been going on with the stay-at-home order and the virus, they've
Right.
stalled for the foreseeable future. But they did ask me specifically when I'd be available later in the year for it. So fingers crossed on that, but that's not something set in stone yet.
Okay. Good. Great. I don't have any more questions. So great job, Nathan. Looks great. Thank you.
Thank you all for your time.
Mhm.
Nathan, great work. Thank you so much, everyone. If you would join me in congratulating Nathan for a job well done.